This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, I'm going to be talking about the ambiguous case of sine rule which appears on the higher level course. The ambiguous case of sine rule only arises when you are trying to find an angle and only when the smaller of the two sides given is opposite the known angle. So down here I have a couple of different triangles and we're going to see which one of these would be an ambiguous case. So the first case, we see we're given the angle of 60 degrees and the side opposite is of length 5 and the other side is of length 7. So in this case it would be an example of an ambiguous case because the side given, 5, is smaller than 7. However, in this second case, we see that now our angle of 70 degrees has 7 as its opposite side, and since 7 is bigger than the other side, 5, this would not be a case of the ambiguous case of sine rule. And our third case here, once again we see that our angle of 35 degrees is opposite the smaller of the two sides, 7, since the other one is 10, so that would be another example of the ambiguous case. The ambiguous case of sine rule basically means that there are two possible solutions for the other angles in the triangle, and we'll see this now in an example. So if we look at this example here, we're asked simply to find the values of the unknown angles to the nearest degree. And we're given this triangle over here, where our given angle 48 is opposite a side of length 15.3, which is smaller than the other side of length 17.6. So we use our sine rule as normal to work out our first angle, and the one we're going to work out is B, since we're given its opposite side. So we use our sine rule as normal by placing the thing we want, which is B, on the top left of our equation, and then we try to work out what B is. So going from here to here, we're just rearranging our equation to get sine B on its own by multiplying up our 17.6. And once we work this out, we see that sine B is 0.854859407. So now we have to ask ourselves, what are the two possible values for B? Well, if you look at the unit circle that you may have looked at before, particularly with our CAST, our cast circle, you'll see that the two areas where sine is positive is in the first quadrant and in the second quadrant, which is written here. So in the first quadrant, we know that our angle B will just be sine inverse, and when we work it out, we just get that our B is 58.7 degrees. And then in our second quadrant, when we want to work out what our angle is, we're going to need to do 180 degrees minus our 58.7 to get our angle. So this angle here, which comes out to be 121.3 degrees. So the last part of this question is going to be to work out our remaining angle, but since we have two different answers for the angle B, we're going to end up with two different angles for the angle at A. So you'll see here in the two diagrams below, our angle at C is 48 degrees and always is. However, here on the left, our angle B turned out to be 58.7 degrees, but in our other triangle it was 121.3 degrees. So, to get our other angle, our angle at A, which I've called Y, we're going to have to use the fact that the three angles in a triangle add up to 180 degrees. So in order to get Y, we need to do 180 minus the sum of our other two angles, which is 58.7 plus 48 on the left, which gives us an answer of 73.3 degrees for Y. And if we do the exact same thing on the right here, we do 180 degrees minus the sum of our other two angles, which gives Y as 10.7 degrees. And you can see from the two drawings here and here that because of the situation we had where our smaller of the two sides was opposite the angle given, we actually have two different answers for what our triangle could look like. And that's the ambiguous case of sine rule.